I know it's been only one day of differential equations, but doesn't it seem like, come on, Dr. Sauer, this doesn't seem like a very challenging element to calculus. Slope fields, I mean, you're just doing what it says and finding the slope and drawing these little lines at every point. A little tedious, but it seems kind of low bar. Well, it is a low bar because we really aren't showing a lot of math prowess doing it. But it is one of the three ways that we're going to find our goal, which was to find, remember that goal, finding y? We're going to find y three different ways this chapter. One, we just did. Draw a slope field, given a point, draw a line. That's a really basic entry-level way of finding a y function, knowing a differential equation. Okay. The second way we're going to look at actually tomorrow. It's called Euler's method. It's very annoying, and you're going to hate it, but it's easy. The other way is what we're going to do today, separation of variable, and then we're going to look at other techniques. So slope field, Euler's method, and then I call the algebra calc methods. These are the ones that show up on tests. These don't very often. Okay, so we're going to start off with separation of variables. This is a technique you learned yesterday that simply says, if I integrate dx, what do I get? X plus c. If I integrate dy, what do I get? Y plus c. So in order to do that, where do dx and dy have to be in order to do that? Numerator or denominator? Both in the numerators. So this is the gist of separation of variables, is when you see dy dx, you can separate them, split them off, so that you get dy equal to x cubed plus 3 dx. The reason you separate them is you want the dy in the numerator and the dx in the numerator, because now you can integrate. And what did we say the integration of dy was? Y plus c. Yep. And what's the integration of x cubed plus 3 dx? Well, it'll be x to the 4th over 4 plus 3x plus c. Now I have a question for you. If you have a y plus c constant here and a y plus c constant here, if they're both constants, can't we just shove them all over into one big bloated constant, c? Yes. And so from now on, what we're going to do as a norm is we're going to put the plus c on the one on the right. Could it be on the one on the left? Sure. But we're doing the same thing every time. Let's just put it on the one on the right. And you'll always see it that way. See it that way. That was a joke. Okay, so x to the 4th over 4 plus 3x plus c. Now, they give us this point. This is old calculus, isn't it? We can find the c. We're not going to do it, but you know what I mean, right? Okay, so that one was pretty easy. In fact, that's what we've done in the past. But what if you have something like this? dy dx equal to y plus 3. Now, y plus 3 is going to be a little different, because now when I put the dy alone and put the dx alone, what happens is that the y needs to be with the dy. So in order to get the y with the dy, we're going to divide by y plus 3 to both sides. These cancel out, leaving dy over y plus 3 equal to dx. How are we doing so far? Okay, what are you going to do next to solve for y? Let's integrate both sides. Once you've separated them, the dx is on the top, the dy is on the top, you just integrate. Integration of this is du over u. What's the derivative of y plus 3? dy. So this is integral of u over du. That's just going to be the natural log of u is equal to x plus c. Now there is a plus c on this left. We're just moving it over to the one side, keeping it real. And now we're going to put in an x and a y in. So this is the natural log of y, which is negative 2 plus 3. X is equal to 4 plus c. Well, what's the natural log of 3 minus 2, or 1? Yeah. So we're going to have 0 minus 4 equals c. c is negative 4. So this is what I call my finding c. Part. So then it looks like we're done, but we're not. We've got a little bit of work left to do. Everything okay so far? Is that all right? Emma, good? All right. So now let's plug in. You have the natural log of y plus c, or 3, equal to x minus 4. Now what we need to do is to solve for y. What do we do next? How many of you remember secret to logs from long ago? Secret to logs is when you think you're stuck. This is log base e. You're going to go e to the x minus 4 equal to y plus 3. So that's just going to give me y equal to e to the x minus 4 minus 3. That is the solution for y that will make this true. Do you believe me? Oh, that's nice. I appreciate that. But let's prove it. Let's prove that it's right. dy dx. What's the derivative of e to the x minus 4? E to the x minus 4. What's the derivative of negative 3? 0. So the derivative, dy dx, should be equal to y, which is e to the x minus 4, okay, minus 3 plus 3. And is that true? Yep. Isn't that cool? So there you go. And we just showed separation of variables. Any questions? Okay, let's go deeper. Deeper and deeper. You try this one. Go as far as you can. So hopefully you were able to separate these into dy over y and x cubed dx. Did you get that part? And then what did you do next? Just integrate. Yep. So the integration of dy over y is the natural log of y equal to x to the 4th over 4 plus c. So we need that plus c because we need to find c. So let's do that. The natural log of negative 3 is equal to 5 to the 4th over 4 plus c. And what's c? What's the problem here? Yeah, no answer. Yeah, so this one doesn't have a solution, and that's okay. It's kind of disturbing, kind of unsettling, but it's okay. Some don't have solutions. This point, 5, negative 3, doesn't exist. So we would say no answer. It is a lot less work, but anyway, all right, let's try the next one. Dy over y equals dx over x. Now this one is going to be interesting because you're going to get the natural log of y equals the natural log of x plus c. Now when you start finding c for this one, by the way, IB loves these questions because they can mark these so clearly. Okay, could you separate it? That's one. Could you integrate it? That's one mark. Could you find C? That's one mark. Here's 1, 2, 3 marks, just as clear as a bell. All right, so then you put in, here's your x, here's your y, so you get natural log of e squared equals the natural log of 6 plus c. What is the natural log of e squared? It is 2, because if you pull the 2 out in front, the natural log of e is 1. So 2 times 1 is 2. 2 minus ln of 6 is equal to c. Now the reason I'm doing this problem is this is going to happen to you a lot. In how do we deal with this 2 minus ln of 6? It's going to get ugly when we put it into natural log of y equals the natural log of x plus 2 minus ln of 6. Well, this doesn't look so bad. When does it get complicated? When I change this, yeah, log base e. When I go e to the natural log of x plus 2 minus ln of 6 equal to y. This is when it gets a little complicated. But I'm going to remind you that what is 2 cubed plus 2 cubed times 2 to the 4th? What is that? 2 to the 3 plus 4, right? So if I have all these added across, why can't I think of this as e to the natural log of x times e to the 2 times e to the negative ln of 6? Is that the same thing? Yeah, but right? But the reason I write it that way is there is some things that will be simplified. What's e to the log base e of x? E to the log base e of x. That's x. So we've got that going for us. We've got the e squared going for us. And then I want you to turn to your neighbor, tell them what this is simplified. I think you're going to get it wrong. But prove me wrong. I was wrong. You were right. This isn't that bad. E to the natural log of 1/6. So it's e to the log base e of 1/6, which is what? 1/6. So this is xe squared over 6 is y. A really weird looking answer. It's a constant times x is what that answer is. You try this one. Oh, by the way, it's one of those answers, A, B, C, D, or E. All right, so you have dy times y equals x squared dx. Integrate those, you get y squared over 2 equals x cubed over 3 plus c. This is my x, this is my y. So I'm going to find c here. So you're going to get negative 2 squared over 2 equal to 3 cubed over 3 plus c. This is just going to be 2. This is just going to be 9. 2 minus 9 is negative 7, right? Okay. So y squared over 2 is equal to x cubed over 3 minus 7. We're going to get y squared is equal to 2x cubed over 3 minus 14. And then I'm going to get y is equal to plus or minus the square root of 2x cubed over 3 minus 14. Love this one. It's devious. So, you got a choice. Is it D or E? Right? It's one of those. What's that? Yeah. It has to be E because see how this y value is -2? Y is negative. The only way you're going to get that negative is with this negative sign. It's the only way. Isn't that special? There you go. And the last one, I just want to show this to you because we've done one like it already. Dy dx is equal to y plus 1, y of 2 equals 0. What's the coordinate for this one? What's the x value they're putting in? 2, and then what's the y? 0, yep. So you just do all the stuff that we've done before. But this Euler's method, I want you to read it, but you're not going to do anything with it until tomorrow. We're actually going to do this tomorrow, but I'm going to solve it with separation of variables today. So you're going to do everything that we've done so far. You'll go dy over y plus 1 equal to dx. And you'll integrate. You'll get natural log of y plus 1 equal to x plus c. And you'll find the c, and you'll do all that good stuff. But it's just, that's all it is. This Euler's method, you just skip that. All right? So for the assignment, you'll see all of these Euler's method things, but you're just going to do the circled parts that say integrate this using such a point. Integrate this using such a point, check another value. Don't do the Euler's method parts for those problems. Got a couple of word problems that'll be good. And then, let's see, 4, 8, and 4. And if you need a little help with 4, there's one worked out on the next page, but I don't think you'll need it. And that's the assignment for tomorrow. And that's separation of variables algebraic method.